After our prolonged mic checks there, we now have Mark Lemmert telling us about updates with Archaist. Take it away.
Check.
No, it's yours on. Oh, is it Leech? You can switch on. You did, Tim. There.
Oops.
How about that? That'll help you.
Helps if I follow instructions.
Check.
Well, good afternoon. As many of you know, I'm Mark Lemmert from 6502 Workshop, and we're working on developing a 8-bit sword and sorcery tile-based RPG for the Apple II called Archaist. And our mission is to explore what kind of advancements may have occurred in those types of games if large-scale development had continued past the end of the 1980s. And today I have some updates to share, including the status of our upcoming Kickstarter, some technical achievements made over the last year, including the unveiling of our splash screen, some Mockingboard music, and some other things. And in classic Kansasfest fashion, I'm going to try to cover all that working on about 2 hours of sleep. So I hope that probably the computer won't need to be rebooted over the course of the session. However, I might be. We'll see how it goes. All right. So let's start with the Kickstarter. So soon we're going to be launching a Kickstarter campaign to produce a collector's edition of Archaist that will include a game box, printed manual, some game artifacts, variety of feelies, and of course most people's favorite, certainly my favorite, cloth map. New and improved from the last one shown here last year. Thanks to largely the efforts of Chris Torrance, who has joined the team and is leading the effort for launching this second Kickstarter campaign. As some of you know, we did launch a campaign last fall, which fell short of its funding goal. As the first, as far as I know, Apple II game to launch a crowdfunding campaign, as you might imagine, there was a lot of guessing involved in putting that first campaign together. And I'm very confident that we're going to nail it here the second time around because we now know what to expect and we've adjusted accordingly. And I've seen what Chris has been putting together and it looks really awesome, and really excited to share that with everyone. As to launch date, we don't have a specific launch date. As a part-time team, as you can imagine, we're working on this as we can. That being said, we're hoping for sometime yet this year for launching the campaign. Okay, well, without further ado, let's check out the Archaist splash screen. Yeah, well, here it is. This is our double high-res splash screen. Thank you. This was a collaborative effort between Bill Gigi, Michael Peresky, and myself. And we're going to talk a little bit about what's under the hood. Starting with the art pipeline. So the art pipeline started with a draft image created in Adobe Photoshop, and we took the Adobe image and imported it into the Outlaw editor to convert it to double high res. Thank you, Martin and Brendan Roberts. We took a screen capture of the double high res rendering in Outlaw, imported that into Buckshot. And then the Buckshot binary output, we took that, imported it into 816 Paint, native Apple II software, and we use that to do the touch-ups to get to the final result. And the 816 paint binary output is the final cooked data that's used by the splash screen program. So before we talk more about the actual splash screen program, we're going to go back to the slides. Well, or we're going to do something. We're going to go into the debugger for absolutely no apparent reason. I'm going to blame it on the sleep thing again. But we'll go back to the slides because I've got some work in process images that kind of show how the art pipeline evolved. And starting with this one, obviously pretty rough. Start to get a little bit more of the outline of the shape here. And get a little bit of color. And then we convert it to an 8-bit cow. Well, how did that get in there? We've had problems with cows showing up in strange places in the game too, so just be aware of that. That's I blame it on our team member who goes by the nickname Electric Moo. I think he has something to do with it. But anyway, back to the slides. A little bit more color in this one, and this one here is pretty much what we just saw in animation as the final result. Okay, well now let's go back to the final version and talk about the splash screen program. Okay, so the splash screen has 4 frames of double high-res animation. Disk space was a huge issue in consideration as the splash screen resides on the floppy disk that is the boot disk, and that has huge chunks of the game engine on it that are getting loaded into memory, the bootloader, some other stuff, so we really had to optimize here for space. And there's a number of things that we did to do that, which I'm going to kind of tick through. We eliminated the screen holes. Each double high-res screen contains 1 kilobyte of empty space because of the way the graphics interleave with the video memory. So we're not going to save the empty space to disk, of course. And another thing we did was we animated the dirty rectangles. So for example, we could have taken, if disk space and memory wasn't a consideration, we could take full screen images, render them one after the other to produce the animation effect. But there's a lot of the screen that isn't changing. So what we did is we took the full screen images, the cook data coming out 816 paint, and imported that into a PC side program that we wrote to extract the data just around the areas of the screen that are changing. So there's basically a rectangle around the crown, a rectangle around the eyes, and a rectangle around the dripping on either side. That's where the actual changes are happening. So basically what happens inside the dirty rectangle stays in the dirty rectangle.
Which makes the name dirty rectangle sound all the more appropriate.
Absolutely. So then what we're left with there is the Nox Archaist title and the border around the screen. That's static. That doesn't change. Doesn't need to be saved over and over again, frame to frame. So that certainly saved a lot of space. And another thing that we did was take a look at what parts of the screen could be drawn more efficiently using an algorithm. And for example, the screen border, that's basically a bunch of lines, straight lines that can be drawn easily with a simple loop, much more efficiently than actually saving the bitmap data to disk. So we put that in place. And another thing we did, which was pretty significant, is we're actually, even within the dirty rectangles, not saving the entirety of the bitmapped data. We're only saving the delta frame data. And the way that works is the PC side program I mentioned that we wrote to extract out the dirty rectangles themselves at a bitmap level then compares each frame against each other to see what are the differences, because even inside the dirty rectangles, some of the pixels are changing from one frame to the next, some aren't. And so really the only information we need to know when dealing with the graphics animation rendering is what's changing. So the PC side program its final output binary file is just the information that describes the pixels are changing, and that's our delta frame encoding. And that binary file ends up in our build process and gets rolled up onto the disk images, and ultimately to floppy disk if the disk images are burned to floppy. And that's what's used by the 6502 splash screen program, which is what's running right now. So numbers, well, what we end up with is 29K. 29 kilobytes is what we've got for the graphics data and the code for the splash screen program that's running right now. And we're not done. That was enough to become viable. And so I'm comfortable showing it. I don't like to show things if I'm not confident they're going to be in the final game for the most part. But there's one further optimization that we have planned, which is kind of bonus, to apply LZ4 compression to the delta frame data, because technically that really hasn't been compressed in any conventional way. And with the LZ4 compression, we're estimating we can get it down to 16K. So that'll free up, of course, more space for cool stuff, and I'm pretty excited about that. And one other thing I was going to mention here about the splash screen program is we ended up playing some interesting memory Tetris in order to get it all to work, because the delta frame data is not actually rendered to the screen directly. At runtime, the delta frame data gets translated into code, or compiled sprites, if you will. And it takes up almost the entire 128K on the machine. And with the graphics pages, of course, being right in the middle of RAM, we end up having to kind of, slot the data in here, shuffle it over there, and, play that game of memory Tetris to get to, the final result. And I'm reminded of Quinn's session last year about compiled sprites, talking about the trade-off between speed and memory with compiled sprites, and how it usually doesn't work out. Memory constraints are just too significant. And I thought this ended up being a really interesting case where it actually did, because essentially the environment that we're running in here with the splash screen, it's like a demo environment, a program that's designed to show off the hardware capabilities of the machine and push it to the limit. We are dedicating 100% of the system resources here to graphics. We don't have a pesky game or something running around and memory hogging all the resources. That comes later in the boot process. And not all splash screens are done that way, but that's how we decided to do ours, because we just thought this would be a really cool image. Some decisions just get made like that, So, that's how it all came together. And next we have some news on the Mockingboard. As some of you know, the Mockingboard support was not in the original design for Nox Archaist. And when asked about Mockingboard support, the official answer was maybe, probably not. And I am actually not here to tell you 100% for sure that Mockingboard support will be in Nox Archaist, but I am here to say that it's looking very promising. We've got a demo to share of a prototype that we're going to go through here, and it's much farther along than I ever thought that it would be, given that we were basically out of memory when we started. So, after the demo, Eric Rangell is here to kind of tell the story about it, how it all came together, and get into some of the technical details on the driver. He and Tom Porter talked to me after our Kickstarter last fall and expressed their enthusiasm for helping to bring Mockingboard support to Nox Archaist. And suffice it to say, these guys would not take maybe for an answer. So here we are. We'll finish booting up the game. Thank you. And thank you, Tom and Eric. I believe Tom Porter did this one. There's some other songs that Eric did, and I lost track of which one ended up in there for this, but I'm pretty sure this was one of Tom's. but I'm also not sure if he wrote it or if he adapted it from something else. I'd have to ask him. So as you can hear, music walking around the map works. The driver is interrupt driven, so we have to toggle it on and off when disc I/O occurs. And we're going to see a delay in the music momentarily for that reason. Right there. That's when the game engine loads chunks of map data from disk, which occurs periodically when walking around the map. And some other times, like we're going to walk into a dungeon here shortly, and there will be a delay on the music when that occurs, and a few other times as well. There's currently only one song hooked up, but the architecture is there for more. Basically, we could not too difficultly hook up a playlist so that there's different songs that play when the player's in a castle versus a dungeon or walking around the overworld map like we're doing right now. And I went the wrong way. But no fear, we can just turn around. So the main obstacle to finishing the implementation is basically freeing up enough memory. Right now, the driver and the music buffer, I shoehorned it into a swap area, and that swap area gets clobbered when certain things occur, like when the inventory module is loaded, or when NPC scheduling algorithm runs, and a few other things. So that's the current state, and if we can figure out the memory issues, then the rest can probably fall into place. Okay, well, we're gonna, as we listen to more of the music, we're gonna check out this dungeon. We've shown dungeons before, but we've added some new things. And for example, picking locks, we're gonna pick the lock on a door. The success-fail on lock picking is determined by the lock picking skill of the character that picks the lock. There's traps. There's a trap saving throw. The saving throw is determined by the dexterity of the character that's picking the lock. And one other thing to mention with the doors, you can tell visually whether they're unlocked or locked. The door handle is larger on locked doors, so the door right next to the player icon in the center of the screen has a larger door handle than the door below. The door below is unlocked, the door next to the player is locked. So we're going to go ahead and pick the lock. And prompts us to select the character because the lock-picking skill matters, as mentioned. We're going to first do it with a fighter-type character. And the picking was unsuccessful. We set off a trap because the fighter had a pretty low lock-picking skill. That particular trap only affected the character that was picking the lock. Other traps do different things. For example, the entire party might be affected. It just depends. And we'll take a look at the character roster. We can see the damage the trap did. Fred's green health status bar is no longer at full, and that was the result of the trap damage. And the damage the trap does depends on the differential between the level of the character and the level of the trap, or maybe it's the lock-picking skill and the level. Some combination of player attributes and lock attributes. So essentially, if a low-level character tries to pick a really tough lock, it's going to get harder and harder to do the higher the level the lock is, and the worse the trap damage is going to get the higher the level the lock is.
Quick question, Will.
Sure.
I was looking at when the screen comes up with list of characters, will that at some point have an indication of the lock picking skill each character has, or does it and I'm just not seeing it?
Yes, in fact, I can show that,
Whoa. Or you can catch it.
or I can crash it. Let's, I said probably the computer won't have to be rebooted, but so far we're down to one. Yeah, the answer is yes. There is a inventory stats screen, and it'll probably work from here. I can show real quickly.
And you can get at that while you're... Okay.
You should be able to get at it from anywhere. We just hit a bug there before, but it's normal. It is intended to be accessible for anywhere. So right here we've got lock picking on Fred is 11, and that's pretty low essentially, and that's why it failed.
So it's 11/12. Is that, what is the 12?
Sure, let me just refresh my memory, but it has something to do with the progress bucket.
So,
Oh, I'm sorry. Lock picking is actually 8. The 11/12 is saying that the progress towards getting to the next skill level of 9 is 11 out of 12, which here obviously I misread the screen, so this interface could be better. We're just trying to fit a lot of data into a tight space. Yeah, yeah, that's certainly an option. Okay, and then we'll just make a beeline back for the dungeon there, where we were. Oh, that's right. We already did that with the fighter, setting off the trap. So let's try again, and this time we'll use the thief type character with a much higher lockpicking skill. And it worked, and the door handle changed to the smaller version, indicating it's now an unlocked door. So doors are not the only things that are locked. They're not the only things that are trapped. There will be a number of lock-picking and trap scenarios in the game with different types of objects. And there's also several different types of locks. Not all of them can be picked, and some locks, in fact, tie into puzzles in the game. So we tried to take the opportunity to integrate some more robust mechanics around things like locks and doors. There's no set character classes in the game like we just saw with the lock-picking skill. It's a skill-based system, and there's other skills in the game such as melee weapons, range weapons, critical hit, dodge, parry, and a few others. And since there's no set character classes, we thought, well, what's going to happen if the player changes the skill focus of a character in the middle of the game? Is the fighter type icon representing the party going to feel appropriate? Or in combat, when each of up to 6 characters is represented by its own icon, are those icons going to feel appropriate for those particular characters? And we figured the answer was probably not. And we want to give the player that flexibility and role-playing experience through how their party and characters are being represented. So we made it possible so that it can be changed. And got a quick demo of that here using the icon toggle key. We're just going to do it with the party icon here. We've got 8 icons to choose from, 4 male and 4 female. And now we're back to the first one. Okay, well, you all are the first to see our new multi-tile dragon boss monster. Thank you. Now, before we fight the dragon, as any savvy adventurer would, we're going to save the game. Now, of course, that we have a save game feature, which we didn't last year. So we'll just save the game quick, and then... unfortunately, it is just the one. So we're going to take, also before fighting the dragon, a quick look at the looting system by opening up this chest right below the player. And this chest has a lock, so we go through the lock-picking routine again. We'll use the thief, and lock-picking was successful. So for looting, chests can contain gold and or items, and the interface allows the player to approach this basically in 2 different ways. If the player wants to only pick the cream of the crop of items and not clog up their inventory with lesser items, so to speak, they can do that by selecting yes or no with each item that's listed, if the chest has multiple items, not all do. Or if the player really doesn't care about that, they just want all the loot or they're in a hurry, the player can press A, and then it will just print a list of the items that were acquired. And those generic names, of course, are going to get turned into something real here very shortly. Those are just in our database. But the other thing I was going to mention on the chests is the chests are all map objects to make it all very flexible. And one of the attributes in the map object record is a level attribute. And we use that to control basically how much gold is in the chest and how good are the items, if there are items. And the result is that chests, they're going to have better stuff in tougher areas and, not as good as stuff or as much stuff in the lower level areas. And in theory, scaling, in between to hopefully give the player a pretty rewarding looting experience if, that's what they're into. Nox Archaist is also going to have a very deep storyline that's tied in with the combat scenarios. So if story is your thing, we've got that too. The goal is really to have all of the classic elements of the tile-based style RPG kind of balanced in there together, so it doesn't feel too much like a grind, and at the same time doesn't feel like it's all story but really no action.
I'm
Yes?
sorry, I keep asking all these
Sure,
questions.
go ahead.
As far as the difficulty goes, is it scaling with the player, or is it in specific areas of the game will be at a specific difficulty level?
It's all area based, and I know that's not the way some RPGs did it. Some RPGs would scale with the player, and we're gonna see how it works doing it based by area. Good question. Okay, well, let's go fight the dragon. Now, the Mockingboard driver and combat is not 100% compatible at this point. It works about 9 times out of 10. We actually can't turn off the music. It's actually not that big of a deal. Because we saved the game. There were multiple reasons for saving the game. So here we go. We'll see how this goes. The dragon's pretty tough, so I don't know. Well, not working out so good. We lost half our party in one round. I don't think we're ready for that dragon yet. And that's actually part of what I think the fun is of having things so that they are scaled by area rather than scaling with the player. Is personally, I like to run into areas, find it, oh cool, let's check out this area and find, whoa, I'm not ready for this area yet. And then I'm going to come back when I am and get revenge on whatever the monster was that took me out. So that kind of fun will be there in spades. And since we're obviously not ready for the dragon yet, things didn't go well, we'll do at least what I would probably do in this situation and reboot the game and restore from where we saved.
Eventually be able to restore without having to reboot?
Probably not. It probably will require a reboot to do that. As far as I know, that was pretty typical on the Apple II RPGs. If there is an example where that's not the case, Becky, of course, is going to have one. Could Bard's Tale do that?
No, Bard's Tale just reload the game.
Yeah.
Oh, that did the reload as well. Okay. Yep. That was the assumption I was operating in under when allocating resources would be that was acceptable based on the past to do the reboot. But anyway, ta-da! We appeared right where we saved. We check out the roster. All the players are alive. All the stats are back. And the game saving is pretty flexible. Whether the player's in a town, a castle, walking around the overworld map in a dungeon, all those places are fair game for saving the game. So. It is pretty flexible like that, and that is all for the in-game demo. Eric Rangell is now going to come up and tell us the story of how we got from maybe, probably not, to what we had here today, and talk about the technical details on the driver.
Okay, thank you.
Yep. So I'll get.
So give him your mic.
Sure. Yep. Going to get the presentation here set up for you. And then once you're done, we'll do some questions, and then I've got one last announcement at the end.
Okay, Mike.
Yeah.
Got about 15 minutes.
Okay.
Thanks.
Well, hi, everybody. I'm Eric Rangell. So by day, I'm a solution architect at a pharmaceutical company in Delaware, but by night, I work on Nox Archaist. Okay, this was an example of finding memory to make this all work. Okay, feel free to take pictures. Naspit Labs is Tom Porter's company. Okay, so who remembers an episode of Open Apple where there was a fake Quinn from Canada?
Carrington, is Carrington here?
Yep.
Exposing quite fake.
Well, if you go back and listen at 10 minutes, 25 seconds, essentially what he's saying is, where's the Mockingboard? Okay, September 2017. That's how it all started. So when I heard that, whoops, previous, I got it.
Yes.
Yeah.
Arrow left.
Yeah, I said, no Mockingboard? I must fix this. I'm going to not sleep until I fix this. So I started thinking, okay, I have some code that I wrote in the 1990s for music, and it's interrupt driven for MIDI. Now, I know that their Mockingboard disk had music construction set demos, and that's ultimately what we drew upon to make an interrupt driver. I was thinking we could double buffer song data from a RAM disk or auxiliary RAM, and ProWTS has features for bringing in segments of memory, but ultimately there is a noticeable delay when you're reading even from a RAM disk. We could try to make it better, but we want to fit into a standard 2E with 128K. But MIDI conversion turned out to be part of the method for producing the music. And I was looking on Facebook, and I found Tom Porter had a MIDI to Mockingboard conversion program. So I contacted him, and he does some pre-processing of the music data. And it's pretty cool the way he does it, because with modern tools, you could create a big text file and run it through an Apple program that reads line by line, and you'll see what you get. And I'm thinking about the architecture playlists for different scenes and a file naming convention to make it easy to find the next song. I was thinking maybe we could have multiple songs per scene, and that's possible if you just advance to the next file number. And we wanted to use modern development environment, so I thank everybody who came up with the Xcode and Git build pipeline, Jeremy, Quinn, and Carrington, and anyone else who worked on that. And so 128K Apple IIe is the minimum compatibility requirement, so I'm also testing it on a GS. And emulators, we have to support AppleWin and Virtual 2, and it turns out Virtual 2 had some challenges with the Mockingboard emulation, so we had to work around that, and we came up with a solution. So if I only had the time to do all this. So we needed help. So who did we find? So that's Tom Porter. He does some games, and if you're interested in like high quality Mockingboard and even high quality 8-bit sound, he's done some very interesting things. For his Mockingboard, he's actually looking to enhance it to do things like sound fonts. So that's pretty cool, yeah. And Becky Berger, anybody know her? Yeah. Well, she's been instrumental in giving us some great technical advice. So we're using community technologies, something called ProWRTS by Hugh Kumba. Okay, yeah, Peter. And we're actually using emulator detection by somebody named 4AM. So Yeah, if you go back to 2015, he did a presentation how your program could detect that you're running in an emulator. And Peter actually adapted that code so we can know whether we're in Virtual 2, and then we scale back the Mockingboard logic. Okay. So what would Lord British do? He'd fit the game to what you have. And we're running in an emulator, 128K. How much RAM do we have for music? The elephants never forget, right? Okay. 1.5K. What can we do with 1.5K? Mary had a little lamb. I don't know. Well, Becky helped us save some memory with some interesting recommendations. So if you know anything about music, the frequencies, when you go up an octave or go down an octave, they double or half. So you could just shift a standard tone row of 12 bytes. And it turns out the lower octaves have 2 bytes. If you look at the Mockingboard manual, and I have one here, if anyone remembers this beautiful little work of art. So the frequencies below middle C use 2 bytes. The frequencies above middle C are all less than 255. So it turns out middle C is actually number 240, so it's perfect. You use 1 byte for these 12 bytes, and then you shift left or right, and you get your frequency. And Becky also suggested using music subroutines for repeated sections, because you heard that there's like an A section, B section, C section. And so I was thinking, well, maybe we need a state machine to efficiently transfer, but I came up with a simpler mechanism of using nibbles to represent the section numbers, and using the F nibble as a marker, like the end of the sections for the song, and then continuing bytes for section 0, which is the A section, and then an FF marker, bytes for the B section, C section, and D section, and an end of file marker. So that's helping us save memory for the song data. And then I had to figure out how to produce this, what kind of workflow. So I'm using a great program from the 80s by Mindscape, and this I gotta turn on. Okay. So this was written by Glenn Clancy with the Bank Street College of Education, and it's called Bank Street Music Writer. So this projector's warming up. I'll show you the demo when we're ready. But I'll just walk through the workflow. So I use Bank Street Music Writer to actually enter the music, and you could enter 6-voice music into Bank Street, and but we're actually only using 3 voices for the game. But it makes it very easy. Let me just go into edit mode. And I've got to click in here. Okay, so here's the 3-voice music. You just enter it into the music editor. And then I had custom code to extract it. So back in the 90s, I actually reverse engineered the data structure. So it's using specific sectors on the disk for the catalog entries, and then there's pointers to the sectors for the songs, and each sector is 1 staff. And then each staff has 18 sections going across and 6 voices. And then I was able to just create songs like just a middle C, and then see what it produced, and then figure out, okay, what does it do with the rest? What does it do with the repeat marker? And that way I was able to figure out how to get all the information out of Bank Street Music Writer. So I had a program that used Amper RWTS, just ampersand commands to read, write, track, or sector, to find the catalog, find the directory entries, then you pick the one you want, and then it goes through each sector, interprets all the music data, and saves it out to a binary file. So I had to look at code I wrote 20 years ago and resurrect it and improve it a little bit to extract the voices to files. So there's some custom code interpreting the music data. So basically, I wanted to get a MIDI file, and what's nice is each voice is there's 6 voices, but each voice is 1 note at a time. So in a MIDI file, you could have 6 tracks. So it can just be a 6-track MIDI format one, and then you just have to go track by track in the order of the music, and you don't have to do any mixing of timing. Okay, so that's the interpretation of the music data. And then there were some glitches that I had to clean up, so I wrote a code to clean that. And then for the repeated sections, I had to do some custom code to figure out where the repeats start and end, where are the first endings, second endings, and how to handle those repeats. So basically, I'm putting markers, keeping a text file of markers, pointers to each beginning and ending byte address of each repeated section. And then at the end, I can figure out the blocks of memory that I need to concatenate. So eventually I create a MIDI format 1 file, and that's also custom code that I started 20 years ago, because I was playing around. When I started taking piano lessons, I asked my dad for a nice piano. I got a Yamaha Clavinova, and then I said, I want to make my Apple play that piano, and I asked him to buy me a MIDI interface, and I got this Passport MIDI interface, and it just had a manual with addresses that you have to poke, and machine code, and ACIA, and it made no sense. I had to figure all that out. So I spent years just building my own little MIDI system to play MIDI files I downloaded off the internet. So I had a basis of that structure. So I have an AppleSoft program where you edit variables for the MIDI number of tracks, type of song, and it can take sequence files that have the raw MIDI data and concatenate it into the format of a MIDI spec format 1 file. Now here's where Tom's work comes in. We're actually using DOSBox. There's a DOS program called MIDI Note, which takes a MIDI file and dumps it to a nice big text file with very descriptive rows and columns of what data is in the file. And then Tom has a key logo program that he adapted, and he's calling it MIDI to Mockingboard. So he has a full version, but we asked him to scale it down to fit into this memory footprint, and he succeeded. Over months back and forth with us, we figured out how to take that the music construction set demo and get the interrupts to work so that it can play that 1K buffer and do it in an interrupt-driven manner cleanly. And then so he has his own driver for his demos, so we test playing the song in his driver, and then I listen to it and then give him some feedback, and Tom actually listens to it for quality as well, and he can make adjustments to make it sound good. Okay? So any of you here, if you're interested, you could help us compose 8-bit Mockingboard music. I have a GitHub repository with this procedure and the code. I could walk you all through it. Just come see me. And I'm just going to play the music as it sounds in Bank Street Music Writer. So it's on the surface, it's low, but you can see it's highlighting the notes. Yeah, so each voice, so there are 3 voices. And you see a repeat section coming up. So after the first ending, that's going to go back to the previous repeat. The beginning, it has a repeat sign there. So you can just follow that.
Did you hold your mic up to the speaker, perhaps?
Yeah. So actually, I wrote this song. It was for a friend whose dog passed away. Perfect for that. Okay, we're done. Thank you.
Thank you. Does anybody have any questions for Eric or I?
Take the mic.
Eric,
Chris?
Yes.
when, let's say you're composing your own music, if you actually wanted to make that, music for Nox Archaist,
Yeah.
is there, can you make it too complex?
What's that? Yeah.
So can you make it, like when you're composing it, can you actually have too many notes or something where it wouldn't actually compress down? Like, is there a limit to?
Well, it'll just sound bad if you have it too complex. So,
Okay.
like what Tom always does, he takes out any drum part and then he reduces it. Yeah.
Got it.
Use the microphone if you talk.
Mike, sorry. Where is it?
It's in your hand.
Ah, thank you. And
Hidden in plain sight.
thank you.
Any other questions for Eric or I?
Why does Eric write songs in G flat?
I studied jazz piano.
Becky?
On the Mockingboard, how many voices are you actually using at runtime?
3.
And the editor you're using there is actually composing 6 notes?
It allows 6, but we're only using 3 when we
Okay,
compose.
what I did with Bard's Tale was I used extra tracks
Uh-huh.
to put silences there. The types of silences I put there is markers I use for the interpreter to let me know, oh, this is where you begin a repeat, this
Oh,
is
that's
where
nice.
you end a repeat. So in other words, I'm actually scripting it in the music editor using an extra track.
Yeah, I think we can actually do the copy protection in the MIDI too. All right, thanks.
Excellent.
Sure.
Dan?
So you mentioned Xcode. Was
Yep.
that what you were using, or did you switch your development?
Well, I'm
environment to-
doing development in Xcode. What are you using for your assembler?
SBASM is the cross assembler that the Nox Archaist engine is
Okay, so
written.
okay, 2 different teams, 2 different platforms. Okay.
Yep.
SBA.
Like always
Yeah,
have
from Tom and Eric, I'm basically just taking their binary files and doing a binary include in SBASM.
Okay.
Any other questions?
Yeah.
I've not been paying attention. Is there going to be another Kickstarter for this?
Yes, absolutely. And as before, box, printed manual, game artifacts, cloth map, and we don't have a specific date, but hoping for sometime yet this year. Any other questions?
Okay, come see me for.
Okay. Last thing I was just going to mention is there are a couple of new team members that have joined 6502 Workshop over the last year, and just wanted to give a quick shout out to them. Jared Califf has joined us, and he has experience with projects like Shroud of the Avatar, Sundog Resurrection, and he's helping us with game design and online community communication. And Michael Presky, we mentioned him in conjunction with his work on the splash screen. He's also one of the 2 active developers on the Applewind emulator. He's also a professional game developer with experience at several large studios, including Electronic Arts. And also Chris Torrance joined the team, who I'm sure he needs no introduction here. You all probably know him from this year at K-Fest, past years at K-Fest, his work in the Assembly Lines cookbook, the Assembly Lines video podcast that he hosts, or just that he's sitting right here. Eric Rangell and Tom Porter also joined us in the last year as community contributors on the Mockingboard project, and many thanks to them as well. So that's all for today. Thanks for coming. Any other questions?
Yep.
Thank you.